Okay, I'm recording this. Today we're going to hit 6.5, 2x2 determinants and Kramer's rule. It's another way instead of, well, I'll show you, but it's another way of doing what we've learned how to do. So we're not going to learn a new uh, operation, it's just a different way of getting the same answer. What I know about next fall so far is not a whole lot. In our Friday meeting, my department chair talked about some of the others of us were concerned that we were going to have to somehow, in addition to providing face-to-face learning, provide online learning like we're doing now for all of our classes. So those people with 6 classes would suddenly be preparing for 12 classes kind of thing. And while we don't have anything official, Ms. Triplett was saying that when she attends these faculty council meetings, she gets the distinct impression that we are not going to have two kinds of class within the same class. It'll be as much like it used to be back in the olden days, a year or two ago, as it can be. No details there. She's just getting the impression from the higher ups that this will not be a cobbled class session. This will end up being very much face to face. Now, I don't know what that means in terms of masks or, anything. I mean, I don't have any idea, but, and nor does she. But she gets the feeling because she listens to people that I don't get to hear to and get to listen to. So that's what I know. We are 2 weeks away from some people being able to sign up for classes for fall and 3 weeks away from everyone being able to sign up for classes for fall. So we're that return committee has got to get their stuff together pretty quickly. Okay, let's look at 6.5 and 8.1. Anybody have anything on their mind about that before we move forward? Any questions? I mean, obviously, I have very few answers. Okay, let's go ahead. I did add this. The final will be May 5th, 6th, or 7th. We will review this week on Monday and Wednesday, and then your final will be Wednesday, Thursday, and Friday till midnight, very much like our other tests have been. The only one that was a little bit different from that was this that opened on Monday and went till Friday. But the others, test 1, test 2, test 4, and the final will be open on Wednesday at noon and close on Friday at midnight. So no change really to that structure there. Okay, we are working on worksheets today. Finding the determinant. Let's just worry on the determinant first, and then we'll talk about what it means. The determinant will be based on what we're looking at here are second order determinants. That means it's a 2x2. It's going to be a square matrix. And what we're going to do is we're going to use this to do something else that we'll get into on number 2 using Kramer's rule. But first thing we have to do is figure out how to figure out a determinant. You're going to multiply crossways. That's 56. Then you're going to subtract from that this crosswise multiplication. 56 minus 8 gives us 48. So 48 is the determinant for this matrix. So the determinant equals 48. We're going to do the same thing all throughout. We're going to multiply here. -1 times 1 is -1. Then put a minus sign, and then multiply there, 30. So we get a -31 as the determinant. Same thing here. -2 times -4 is 8. Then put a minus sign, and then 14 times 6 is 84. So 8 minus 84 is a -76. That's the determinant. We'll use capital D for that. Then grab your calculator because nobody feels like doing that. But if you do feel like doing that, it's 2/3 times -1/6. So we're going to do some canceling here, 1 and 3. So we get -1/9 when we cross multiply there. -1/9, just to remind you that you actually do know how to multiply fractions. But if you don't feel like it, grab your calculator. We're going to do 2/3, so 2ABC3 times -1/6, -1ABC6 equals, and we get -1/9. Then put a minus sign because we'll always subtract undeterminants. Then we're going to multiply 2/3 times 5/12. Again, we've got some canceling we can do on the 2 and the 12. That's a 1 and a 6. So we get 5/18 multiplying straight across. Or use your calculator. 2/3, 2ABC3 times 5ABC12 equals 5/18. Okay, now we're subtracting those two. -1/9 minus 5/18. We need a common denominator. For 9 and for 18, that common denominator is 18. -5/18 won't change. 9 goes into 18 twice, so we're multiplying the numerator times 2 also. Now we've got 18ths. I owe you 2 and I owe you 5, so we get -7/18. If you don't feel like doing that, don't. -1 ABC9 minus 5 ABC18. We get -7/18. So the determinant is -7/18. There's the answer for that one. Okay. We're not going to use fractions here. These will all be whole numbers. They're just reminding you that you know what you know about fractions. Okay, let's look at this first problem. This is a two equations in two variables. And let me write it down over here so I can show you something that you know about it. X plus y equals 4. X minus y equals 2. You know that we can add these two together. We eliminate the y's. 2x equals 6, so x equals 3. And then we can plug back in x plus y, 3 plus y equals 4, and get y equals 1. So these two equations right here will cross at 3, 1. That took me, 30 seconds to do that, and that involved all the narration. I mean, it would have taken 15 seconds to get it done. We're going to now take minutes, solid minutes, to get the same exact answer. The answer where these two lines cross is 3, 1. But we're going to use Cramer's rule this time, so it's going to take us forever because you don't know how to do that in theory unless you've seen it somewhere else. And I'm going to be explaining it slowly. So it's going to take us forever. We're going to do several more. We've got this one to do. We've got this one to do, and then this one to do. And then I'm going to give you another one to do. So we're going to look at this plenty of times. Why would we need to find another longer way to do this? Well, what we're going to have here is a 2 by 2. We're going to grab their coefficients, 1, 1, 1, -1. There's the basic second order determinant for this set of equations. If we get bigger than that, if we got 3 equations in 3 variables, then we end up, well, we learned how to use the system of winnowing it down to 2 equations in 2 variables with 2 keeper equations, blah, blah, blah. We also learned how to do the matrices with the ones, the diagonal ones going across, where you were multiplying row 1 times oh, it's fun to get old. Just wait, you'll get there. Multiplying times the reciprocal of the number to get a 1, and then to get a 0, you're multiplying that one line times its opposite and adding in that other row. So we've got a couple of ways of doing it, and as these get larger, computers handle them using determinants. So let's practice that a little bit. And of course, I know you can get the right answer in 2 seconds, but I want to see your determinant process on the test. So what we're going to do here is we first have to figure out the general determinant here. So the general determinant we're going to look at this that was made up of the coefficients of the x's and the y's, 1, 1, 1, negative 1. So let's multiply, doing the same thing we were doing on number 1, multiplying across there. We get negative 1. It'll always be subtracted. 1 times 1 is 1. We get a negative 2. So the determinant, the basic determinant, the general determinant here is a negative 2. Okay, that's going to matter to us. Now what we need to determine is the determinant for x. The determinant for x is going to be a 2 by 2. It's going to be a second order determinant also. It is based on this one, except instead of putting in the x numbers, we're going to put in those answer numbers in their place. So you know that these are the x's, those are the y's gotten from x's and y's. These are the x's. We're still going to keep the 1 numbers where they go. Sorry, the y numbers where they go. The y column will stay the same, but the x column will be substituted by the answers 4 and 2. Okay, so let me go over that again. If you caught it, if you know what I just did, then don't pay any attention. I'm just going to say it again. We have this determinant as our general determinant based on the x, y's. When we're finding d sub x, when we're finding x's determinant, we're going to take this exact thing, except in place of the x's, because we're trying to find the x determinant, we're going to substitute the 4 and 2, the answers, the constants over there. And then we're going to do the same thing. We're going to multiply the determinant. We're going to multiply 4 times negative 1 and get negative 4, then put a minus sign, multiply 2 times 1 and get a 2, so we get a negative 6 for d sub x, for the determinant of x. Okay, let's find the determinant of y now. It's still going to be a 2 by 2 determinant, a 2 by 2 determinant, second order. But if we're looking for d sub y, we're going to keep the x numbers, put that column where it goes, and then in place of the y's, we're going to put the answers, the constants, 4 and 2. So we're going to have 3 determinants here. We're going to have the general determinant that is made up of the x's and the y's. We're going to have the x determinant that is the same second order determinant. You're just going to put 4 and 2, the answers, in place of x because we're trying to find the x determinant. And then for the y, we're going to have this same determinant. We're just going to be putting in the 4 and 2 in place of the y column. So let's do our little cross multiplying thing. 1 times 2 is 2, always a minus sign. And then 1 times 4 is 4, so we get a negative 2. Okay, so we're armed now with what we need. Now we're going to find 3 and 1. We're going to find our answers. X equals the determinant of x over the basic determinant, and y equals the determinant of y over the general determinant. So when we're looking for 3, when we're looking for x, we're going to put d sub x in the numerator and the general determinant in the denominator, and that'll give us a 3. Sure enough, we got that. This one needs to be a 1. We know the answer is 1. We're just going to have to find it with determinants. So d sub y is the numerator, and the general determinant goes on bottom. And sure enough, there, we get our 3, 1 answer. So we have 2 ways of doing that. We have our add, eliminate. We could also do substitution. We could also do graphing for sure. So we have those old-fashioned ones. And then we have this Cramer's rule that we're going to use. You'll see them talk about that you have to first determine if you can use Cramer's rule. What that means is if you get a determinant, a general determinant of 0, you would be putting zeros there in the denominator, then you cannot use Cramer's rule because we don't divide by 0. You don't have to worry about that. They're not going to give you a problem that has a general determinant of a 0. So when they're talking about that, you can kind of ignore it. For our pay grade in this class, we're not going to worry on if we get zeros there. Okay, let's do another one. Here's the same sort of thing. It's in x, y equals a number. So it's ready for us to do all three steps, the general determinant, d sub x, and d sub y, in order to find where the two lines cross. We're still just finding where the two lines cross. Okay, so I'm first going to write myself just the basic determinant based on the x's and the y's. So I've got 2, 1, and 7, negative 3. That is our second order determinant that we will use to find all three of these steps. So the general determinant is just this xy configuration. So I'm going to find the determinant here. 2 times negative 3, it's negative 6, then we always put a minus sign. 1 times 7, so I'm getting negative 13 for the general determinant. So the denominators here will be negative 13s, which makes me a little antsy because negative 13 isn't a nice, pretty number. But don't worry, these work out. Now let's look at d sub x. We're looking for the determinant of x. It also will be a 2 by 2. And man, if you're ahead of me, if you've kind of gotten the hang of this, great. This is not difficult. It's just different. So we're going to take this second order determinant, but because we're looking for the x's, we're going to be putting our answers in for the x column. So 8 and 2 will go there. The y column won't change. So when you're looking for the determinant of x, d sub x, you're going to put the answers in place of x. Okay, let's work on the cross multiplication here. So 8 times negative 3 is negative 24 minus, determinants are always minuses, 1 times 2 is 2. So we get a negative 26, and you can see how those relate to each other. That's cool. Let's look at d sub y. Again, it's going to be the same size of determinant. I'm concerned about finding d sub y, so the answers, 8 and 2, will go in the y column. I'm going to keep the same x column. And then I'm going to do the determinant there. So 2 times 2 is 4 minus, it's always a subtract in the middle. 8 times 7 is 56. So we get a negative 52 there. Okay, let's go about finding x and y. Let's get our answers. X is going to be d sub x over the general determinant, y over the general determinant. So let's see, d sub x is a negative 26. The general determinant is negative 13, so we get a 2. And then d sub y is a negative 52. And the general determinant is negative 13, so we get a 4. So these two lines cross at 2, 4. X comes first, you know that. That means 2, 4 should work in both of these equations. 2 times 2 is 4. 4 plus 4 is 8. Works there. Then 7 times 2 is 14. Minus 3 times 4, that's 14 minus 12 equals 2. Works there. So it's the only set of xy point that will work in this equation. So we find the exact same information as if we had, let's say we had multiplied this equation times 3, so we'd have a positive 3y there and a negative 3y there. Same process, not same process, completely different process. Same answer. Got to be the same answer. Truth is the truth no matter how you find it. This is just another way of finding it. Okay, let's go to our next page, see what we're doing there. Okay, and you can see we could cross out the two y's. We'd have 11x equals 22, so x equals 2. I mean, right there, I've got half the problem solved because it was a very easy setup here. But are we going to do it the easy way? No, we're not going to do it the easy way. We're going to do it the challenging way, the new way, probably more complicated way. But in the end, it's an easier way if we were to get larger and larger matrices. Okay, so let's build the basic determinant. Notice that their xy equals a number. That's what we need. So we got 5, -2, 6, 2. Okay. We'll take that determinant, that second order determinant. So we're going to be multiplying there, multiplying there. Always it's got to be the first times the fourth. 5 times 2 is 10. Minus, and then -2 times 6 is -12. So we end up with a 22 there. This is the first time we've had minus a negative number. And I know you know minus a minus is plus a plus, but just watch out for that. See what you can do about setting up d sub x. We're going to base it off of this original determinant, but because we're looking for the answers for x, we're going to put 4 and 18 in the x column. The y column will stay the same. So 14 times 2 is 28. Oh, 4, sorry. 4 times 2, 8. Minus, and then -2 times 18 is 36. Let me start that over. I messed that up all the way around. 4 times 2 is 8. Then we've got a minus sign. And then 18 times -2 is -36. So we've got plus a plus right there. So that gives us 44. And you can see the relationship. That's good. You know that there's a relationship between 22 and 44. And then d sub y, set that up. We're going to base it off the general determinant. But in this case, because we're looking for the answers for y, we're going to put 4 and 18 in the y spot. 5 and 6 will go there. X's stay the same. And do our little cross multiplying thing. Use your calculator if you need to. 5 times 18 is 90. Put a minus sign. 4 times 6 is 24. So we get 66 for that. Okay, let's get our answers. So x is d sub x over the general determinant. Y is d sub y over the general determinant. So we've got 44 over 22, which is 2, which is what we got over here. Remember, 11x equals 22, so x equals 2. That's not a surprise. And then d sub y is 66 over the general determinant. We get a 3 out of that. So 2, 3 is the answer where the two lines cross. Okay, let me give one to you to do. I'll give you about 5 minutes to work on it. I'm going to help you get it started. Let's see. Let's look at 3x equals 4y plus 5, and 2x equals 9 minus 3y. Okay. First thing you got to do is get that in the proper order. xy equals a number. Neither one of them is in the proper order, so let's work on that. Let's get this y moved across. So this will become 3x minus 4y equals 5. And then the second equation, bring the y across. So you'll have 2x plus 3y equals 9. There's the set of equations. I'm going to give you about 3-4 minutes to get this one solved. See what you can do about doing the determinants for this one. So it is 8:24. Come back about 8:29. Maybe not quite that. Good, that's what you should get. Yeah. Okay, my guess is that's probably enough time. Let's see. Okay, the basic determinant here will be 3, negative 4, 2, 3. So that's the big D. Going to do crosswise, so we get 9 minus, and then negative 4 times 2 is negative 8. So we're getting plus a plus, and 17. That probably made you a little bit nervous right there. Makes me a little bit nervous. Then we're looking for D sub x. So we'll keep the y's the same as they were, but in place of the x column, we'll put the answers, 5 and 9. And again, we'll cross multiply. 15 minus negative 4 times 9 is negative 36. So we're adding those two together and getting 51 there. D sub y, doing the same thing, grabbing the original basic determinant, keeping the x column, but in place of the y column, we'll put the answers. So we get 27 minus 10, or 17. So let's get our answers for x. I did that before. There we go. And y. So d sub x is 51 over 17. That'll give us 3. And then 17 over 17, which will give us 1. So these two lines cross at 3, 1. Wonderful. Okay. Anybody have any questions, any problems, any concerns about that problem? Okay. Let's go back to where we were. Let's look at number 3. Good to have you, Ashish. Let's look at solving for x. This is the same thing, except they're giving you the answer and they're missing one of these. So there's nothing new here. Just set it up like an algebra problem. This is a second order determinant. And so they're getting negative 21 out of it. You know how they did that. They multiplied those two. So negative 7 times 3. Then they're going to subtract. Then they're going to multiply the opposite diagonal, 4 times x. And that's going to give them negative 21. So the rest is just basic algebra. I mean, algebra 1, basic algebra. You have to know what to do here. But this now is very simple. So we've got negative 21 minus 4x equals negative 21. Add 21 to both sides. Yeah, good. Add 21 to both sides. We get negative 4x equals 0. Divide both sides by negative 4, and you get x equals 0. So that guy right there is a 0. And sure enough, you can check it. Negative 21 minus 0 will give you negative 21. Okay. We're going to do a little more than set this one up. This one is a third order determinant. You can see it's a 3 by 3. It's a third order determinant. Let's see. Third order determinant. It's a 3 by 3 square matrix. And what it's broken into is its numerical factor. The numerical factor is, let me use a pencil on this, so I want to erase it. This is the numerical factor, the first row and the first row and the first column. That's called the numerical factor. Can you see that we've got a 7 right here? We're going to multiply times the determinant. Then a minus sign because we subtract on these things. And there's the 1. And then we're going to add the 8. So we're using this column as our helper column. In fact, sorry about that. I got carried away. The numerical factor is this. This is our numerical factor. 7, put a negative on the middle one, add the last one. So that's our numerical factor. That's why I'm using a pencil. Then what we're going to have is, and then what that leaves us with, that we're left with when we also don't consider that, is a second order determinant. So this 3226 is an important thing. Okay, let me get rid of my erasers and show you what we're going to do. This process right here is called an expansion of minors, M-I-N-O-R-S, an expansion of minors. And it would allow us, it is going to allow us to figure out what we've got here. So what we're going to do is when we're using 7 as our numeric, in this piece, this minor piece right here, this piece in here, this determinant that we come up with will be our minor, and that's what we have to fill in. Take 7, ignore his row and his column, and see what's left. That's the determinant 3226. That's the minor determinant of this guy. Now what we're going to do is we're going to do our second expansion. I'm going to erase these lines again. But this time we're worried about our 1, and he has to have a negative here. You'll just have a negative there. Your book doesn't even do much more of a job of explaining it, but it has to do with why we subtract here. That's why this is happening on the middle one here also. So what we're doing when we grab the 1 with this expansion of minors, to get its determinant, we're ignoring his row and his column. So the determinant that is left is 5426. And then finally, when we're considering the last in our numerical factor, when we've grabbed out the 8 and we're going to expand him, we're going to ignore his row and his column, and we're left with this determinant, 5432. Okay? So let's get a number for the determinant for this third order, for this 3 by 3 square matrix. Let's come up with that one. Now we can do that. It's going to be 7 times what we get in here, and that's going to be 18 minus 4, so that's going to be 14 there. Then minus 1 times 30 minus 8, which gives us 22. And then plus 8 times this determinant is 10 minus 12. So we get a negative 2. So we're doing these, we're just getting more practice doing these second order determinants. When you go to do this on my math lab, they're going to give you this entire 3 by 3. Then they're going to give you exactly what I gave you, 7 times, and you're going to have to fill that in, minus 1, and you're going to have to fill that in, plus 8, and you're going to have to fill that in. And that's as far as you're going to have to go. They're not going to make you go further than that. So, you know, whatever. Okay, let's see, 28, that gives us 98, minus 22, minus 16, so that's 98 minus 38, so it looks like 60. I don't know if any of you use your calculators, but if you got something different than 60, holler. So we've got a 3 by 3 square matrix. This is the way to break it down. You can imagine what a 4 by 4 matrix would have been. Yes, I can do that, Chloe. You mean how I just produced these numbers right in here, or how I got the 14? Yeah, okay. So the way you're going to do this 3 by 3 is we're going to take these numbers. So we've got a 7 times what's left over when we kick out the 7. So when we kick out the 7 here, we're going to kick out his row and his column. And what I have not crossed out is his 2 by 2 determinant, 3226. That's all it is. So then when I go with a minus, because it's required to be a minus for the middle guy, and now I'm going to go grab the middle one on this row, on this column. I'm going to grab this 1, so minus 1. And when I do that, to figure the rest of his determinant, his 2 by 2 determinant, I'm going to ignore 1's row and 1's column and see what I didn't cross out. I didn't cross out 5426. So that's his determinant, 5426. And then finally, we take the last guy in that first column, 8, and we'll be multiplying him times what's left over when we ignore 8's row and 8's column. If we get rid of 8's row and 8's column, this is what we haven't crossed out, 5432. Ah, good, good. It's always wonderful to have somebody ask, because maybe somebody needs to get a coffee break or a pee break, or somebody needs to know the same information. So thank you for asking. Okay. Anybody else have a problem with any of this? We're done with determinants. You will not on MyMathLab have to do this step. You will just have to do that step where you've got to fill in the rest of the determinants, the 2x2s that remain. Okay, let's go to chapter 8 now. Let's look at what we're doing there. Remember, I told you the rest of this class is just like you got up at the top of the, you climbed up to the top of the ladder on the slide, and now you're just sailing down. Okay, this section that we're doing now is 8.1. We're going to learn a little bit about sequences and summation notation. Summation notation. Sounds like, I don't know, what was that little show? Anyway, Electric Company sounds like. Okay, we're looking at sequences first. We're going to look at a general sequence, general equation for a sequence. A sequence, by the way, is just a group of numbers. That's SEQUENCE. It's just a group of numbers that has a pattern. 1, 2, 3, 4, 5, ... is a sequence. 2, 4, 6, 8, ... That's a sequence. So for our first one, we're going to look at A sub n equals 7n plus 3. That's the general equation for a sequence. N being the nth term, we talk about nth term, like first term, second term, third term, fourth term. Nth term is just the general one. What they want from you here is the first 4 terms. And then we will determine the 357th term. Okay, let's look at the first 4 terms. A sub 1, the first term. If 1 is the n, then we're going to put a 1 right there. So 7 times 1 plus 3, which gives us 7 plus 3, which gives us 10. So A sub 1 is 10. A sub 2, the second term in this series, we're going to put a 2 in for n. 7 times 2 plus 3. So that's 14 plus 3, or 17. Next term, we have to find the first 4 terms. So we're looking for A sub 3. And again, whatever the n is, that's what you put over here. This will be telling you what you're doing. This will be doing it. So we want to go after the A equation, and we want to plug a 3 in everywhere we find an n. We've done this sort of thing before. Looks a little different here, but it's the same sort of process. This tells you what to do. Over here, you do it. 21 plus 3 is 26. There's something desperately wrong with that. What did I do wrong there? 21 plus 3. There we go. 23. 21 plus 3. 23. 24. Crap. 21 plus 3. 21. 22. 23. 24. That makes this 24. There we go. See, the pattern is we're adding 7. 1 more 7. 1 more 7. 1 more 7. You can see that sequence is 10 to 17 to 24 instead of whatever I was trying to make it. Let's look at the last one that they're asking us to find here, the first four terms. Grab the A equation, it's right here. Plug in 4 everywhere you find an N. So we get 28 plus 3, which is 31. So our sequence looks like 10, 17, 24, 31. We're not going to find past there, except we are going to find the 357th term. So A sub 357, going to grab the A equation, plug in 357 everywhere there's an N. So 7 times 357 plus 3, I'm not going to rely on my brains right now. 7 times 357 equals, plus 3 equals 2502. 2502. Okay. All right, let's move to another general term. Let's play around with something different. Let's look at A sub n equals negative 11 raised to the nth power. And again, we're going to find the first four terms and then the 357th term. There is a reason for this, and I'll show you in a minute why we're doing that. So we need A sub 1, we'll need A sub 2, A sub 3, A sub 4, and then we'll do A sub 357. Okay. Grab the A equation, that's this one. Everywhere there's an N, put a 1. So there's an N. So I'm going to put a 1. Negative 11 to the first power is just negative 11. Grab the A equation, and everywhere you find an N, put a 2. So we get 121. Negative 11 times negative 11. Be sure if you're using your calculator that you're using parentheses because you want the negative squared also, and your calculator doesn't know that unless you tell it that. Okay, next let's do the same thing, except this time put a 3 there. Put a 3. We're raising it to the third power. So we've got negative 11 raised to the third power. In parenthesis, negative 11, close the parenthesis. Humpy, third power. You get negative 1331. That makes such a nice pattern there. I took this most wonderful class in my master's. Oh my gosh, it was a wonderful class. And part of it was finding patterns. So what I would guess this next one would be a positive because we're going negative, positive, negative, positive. Let's put a 1 on each end. When we're raising it to the second power, we've got 1, 2. We've got 2 3s. Let's put a bunch of 4s in there. See if that's right. Negative 11 raised to the fourth power. So we can multiply this times another negative 11, which is fine, times negative 11. And there we go. We got 14641. So why did that happen? We won't be exploring that in this class, but just patterns of numbers are so cool. Okay, so this series, this sequence is negative 11, comma 121, comma negative 1331, comma 14641, dot, 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 raising it to the 11th power. Yeah, it's going to, oh, okay. Chloe, are you using this calculator? It shouldn't say overflow. Did it have times 10 to the? This one will handle it. I mean, it still has times 10 to the. Maybe it doesn't. Let's look. Parenthesis, negative, and I'm so thrilled that you're ahead of me. 357 equals, oh yeah, sure enough, I have never seen overflow error. That's interesting. This is the first time I've done 357 on this one, and I obviously didn't try it. What it normally does, I mean, it's just so enormous. What it normally does, you know, like if we do, let's say we do 11 raised to the 15th power, there we've got 4 decimal point, times 10 to the 15th. So this is just too overwhelming for it, so it can't do it. But you know it exists. Overflow error just means that your calculator couldn't handle it, but it does exist. And we could put it in our calculator to find it, more importantly. That's going to be important in a minute. Okay, let's look at A sub n equals 2 times n over n plus 12. Let's do the same thing. Let's look for the first 4 terms, and then let's find the 357th term. So let's look for A sub 1. So you know what to do. Take this equation, and everywhere you find an n over here, put a 1. So I'm getting 2 over 13. Looking for A sub 2, same thing. Put 2's in those spots. So we're getting 4 over 14, but you got to reduce that. If you don't feel like reducing it, let your calculator reduce it. So we're getting 2/7. 2 times 3 over 3 plus 12. So we're getting 6 over 15. Again, ask your calculator to reduce that. A sub 4, 2 times 4 over 4 plus 12. So we're getting 8 over 16. So we're getting 1/2 there. Okay, so that's our sequence. Let's look at A to the 357th. 4, carry the 1, 11, 6, 7 over 369. I don't know if that will reduce or not. 714, ABC 369. And then second, ABC equals. And there we go. Reduced a little bit, reduced by 3. 7, 8, 9, 10, 11. Yeah, because the sum of those digits divides by 3, and the sum of those digits divides by 3. So we get 238 over 123. Okay, so we could find it. We could ask our calculator to do it, and because it wasn't huge, our calculator could do it. Okay, now let's look at another kind of general sequencing term. These are called recursive ones, or this is called recursion that we're going to be looking at. Recursion and recursive sequences. Everybody hear me okay still? That was a little weird noise on my computer. Thank you. Okay, let's look at what we're doing here. On recursive sequences, you have to know what the previous guy was. They're going to give you the first one. A sub 1 is 5. They're going to tell you the general formula. A sub n is A sub n minus 1 plus 8 for n is greater than or equal to 2. Okay, let's see what that means. If they only gave us this piece, and we were looking for A sub 1, we're not going to be because it doesn't qualify here. They're giving us the answer, and it says our n's have to be equal to 2 or bigger. So right here and right here, we're told, don't go looking for A sub 1, but let me show you what would happen if we were looking for A sub 1. Then we'd have to put, it says grab the A formula, that's this one, put a 1 in place of n. So we'd be doing 1 minus 1. That gives us a 0. There is no A sub 0. We don't have access to that. We don't know what that is. So we will not be finding A sub 1. They will be giving it to us. Now we can go and find the others. And this, again, will ask you for the first 4 terms. So let's do A sub 2. A sub 2 says go grab the A formula, and everywhere you find an n, put a 2 in its place. So this will be A to the 2 minus 1 plus 8. 2 minus 1 is a 1. A sub 1, oh, we know what that is. They gave that to us. That's a 5. So we get a 13 for that because 5 plus 8 is 13. So what we're going to cook up here will be the answer to the previous one. Let me show you how that works again. A sub 3, we're going to go after this equation. So A sub 3 minus 1. 3 minus 1 is a 2. So they're asking us to find a sub 2. We found a sub 2 already. It's a 13. 13 plus 8 gives us 21. Let's do that again. A sub 4, grab the A equation. Everywhere you find an n, put a 4. So we're going to do a to the 4 minus 1 plus 8. 4 minus 1 is 3. A sub 3, we found out, was 21. 21 plus 8 is 29. So this recursive formula, recursive just means that you have to recur. You have to go backwards a step. You have to go back to the previous answer and then do something else. That recursive sequence then is 5, 13, 21, 29, and then we would carry it on. So we have this sequence. You can see that it increases by 8s because that's what we're doing here. We're taking something and increasing it by 8. Taking the previous answer, increasing it by 8. Taking the previous answer and increasing it by 8. So let's go find a sub 357. Let's go find the 357th term. That means we're going to have to find 357 minus 1. So we're going to have to find the a sub 356. Well, we don't have that. We have a sub 4, and that's not going to help us any. We're going to have to go, what we'd have to do on a recursive formula is that you cannot jump in and just grab any number you want. You have to work your way up there. We would have to get to a 356. We would have to then, in order to find 356, we'd have to know a sub 355. And in order to have to know 355, we'd have to back up and go to 354. So what we've got here is a problem because we're not going to be able to jump to any number we want. Where we could on the other formulas, we just plugged in the n. They didn't have this little trap of n minus 1. The most wonderful way I saw this described is that these that we just previously did, this kind of a formula where they're only asking you for n's, this general formula for sequences, that's like being on the elevator. And when you want to go to got the little doors there, when you want to go to a floor, you just put it in, 357th floor, and you're there. You get in and you're there. Whereas a recursive formula, you've got to go climb the stairs all the way up. In order to get to the 357th floor, you've got to climb all the floors one at a time until you get to 357. You can't just take the elevator like we do on this general sequence. Okay, so let's look at another recursive formula. They've got to give you the first one. No. Nope. That would be too painful. You're not going to be asked for A357. Just making a point. I don't even know if they even talk about it. I just think it's cool that we've got two different kinds of formulas. And we could certainly make this one into a general formula. This is just A sub n plus, well, we've got A sub plus 2. I'd have to work on it a while. It's been a while since I've converted formulas. It's not difficult, though. Let's look at A sub 1 is 2. Let me give you the general formula. The general recursive formula will be 5 times A sub n minus 1 for n is greater than or equal to 2. So they're going to spot you the first one. That's really kind of them. So A sub 1 equals 2. Let's go work on A sub 2. 5 times A to the 2 minus 1 is what we're working on here. 2 minus 1 is 1. And A sub 1, they gave it to us, is 2. So 5 times 2 is 10. Let's look at A sub 3. Again, we're going to plug in a 3 over here. So 5 times A sub 3 minus 1 is a 2. A sub 2 was 10. So 5 times 10 is 50. A sub 4 is 5 times A sub 4 minus 1. 4 minus 1 is a 3. That's always going to be the previous number. So that's a 50. So we're getting 250 there. You can see you're just multiplying times 5 each time. Taking the previous one and multiplying times 5. Okay, we're not going to do 357 because you'd have to climb up stair by stair by stair. Okay, let's see what's next. Next, we've got A sub n equals n squared plus 1 over n plus 2 factorial. We're going to learn a new trick here. You may know it. N plus 2 factorial. Factorial just means multiply that number on down to 1. So if we had 4 factorial, it just means 4 times 3 times 2 times 1. It's nothing fancier than that. So 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. That's all that factorial means. It's kind of fun to say that's 4, and that one says 7, like that, but that's sort of dorky, so you do what you need to do. Okay, let's look at the first 4 terms here. Let's look at A sub 1. Now you might have noticed there's no n minus 1s, there's no A sub n minus 1s. So this is not a recursive formula. This is just back to our basic sequence formulas. So let's see, if we're looking for A sub 1, we're going to put a 1 in there and a 1 in there. So we get 1 squared is 1, 1 plus 1 is 2. Down here, 1 plus 2 is 3, so 3 factorial is 3 times 2 times 1. So we get 2 over 6, which reduces to 1/3. A little bit of math in that, not too painful. Let's look at A sub 2. Again, you're going to put 2's in here. So we got 2 squared plus 1. Then on bottom, you got 2 plus 2 factorial. So we got 4 plus 1, which will be a 5 on the top. It's an n squared. Let's see. Let me look at what you said again, Chloe. Is that a 2 on top of the n? That's n squared. Is that what you're asking about? Okay. Yes, so 1 squared, 2 squared. So this is going to be 2 plus 2 factorial. So that'll be 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is 24. So we get 5 over 24 there. Let's look at A sub 3. Go back to the original formula. That'll be 3 squared plus 1 over 3 plus 2 factorial. 3 squared is 9. So we got a 10 on top. 3 plus 2, that's 5. So this will be 5 times 4 times 3 times 2 times 1. You make your life a little less painful. Let me show you where the factorial button is on your calculator. Get rid of, there we go. That's a little bit better for you. The factorial button is hiding under the PRB button. So push PRB, and there's the factorial key for you. So you arrow over to that one, but you got to have the number in place first. So let's say we're looking for 5 factorial. Put a 5 in, and now we need that exclamation point. To get to that exclamation point, push the PRB, and then scoot over so that the exclamation point is underlined, and then just hit enter, and you'll have 5 factorial, and hit equal, and it'll tell you it's 120. 5 times 4 is 20. 20 times 3 is 60. 60 doubled is 120. So you can use that button that hides under the PRB. This is for other status stuff. Scoot over, and then you've got it underlined there. Or you can just, hammer it out. 5 times 4 times 3 times 2 times 1. So we get 120, so that gives us 1/12 for a sub 3. This is the best calculator. It does so many cool things. And if you take, what's our course? Well, stats is loaded with it, but you may end up with a different calculator for stats. But our lowest level kind of math for this level, it's called something, uses those keys a bunch. Okay, let's do a sub 4. We got 4 squared plus 1, that's 16 plus 1. So it's 17 for our numerator. And then 4 plus 2 factorial. 4 plus 2, you know, is 6. So we got 6 times 5 times 4 times 3 times 2 times 1. And, you know, timesing times 1 doesn't do anything. So let's do 6 factorial here. Put in 6. And then go grab the factorial key. So PRB, scoot over using your little arrows. And there's 6 factorial equals 720. You could have just taken 120. The only difference here between 5 factorial and 6 factorial is it's times 6. So you could have taken 120 and multiplied it times the 6. That's the only difference there. Just throw in the 6. And then 17 over 720, pretty sure 17 ABC 720. Nope, it won't reduce. So that's a good answer. We're not going to do to the 357 because that is going to overload your calculator. 350 probably. Let's see. Let's see if we can do 357 PRB. Boop boop. Yep. Once again, nope, not going to do it. Okay, let's play around a little bit with factorial. You're going to have to evaluate something like 18 factorial divided by 16 factorial. Don't do that. Don't start grabbing your calculator. 18 factorial, think about what it means. 18 times 17 times 16 and on down. I'm just going to put dot, dot, dots for that. 16 factorial is 16 times 15. We can cancel those completely out. So 18 factorial divided by 16 factorial takes out all but 18 times 17. So this is what you want to do right there. So you're just doing 18 times 17 and leaving it at that, 306. If you were to multiply it all out, you get the same answer, but this is much quicker. Let's look at summations. This is the other thing that 8.1 includes is summation notation. Summation means you're going to be adding stuff together. And the summation notation looks like that. We've got some notation we got to learn here. That's the way that's going to look. And what this says is that we're going to start with 1 and we're going to stop where j equals 6. So j equals 1, j equals 2. I'm going to do a bunch of different little problems. J equals 4, j equals 5, and j equals 6. For each of these from 1 to 6, I'm going to be adding them up. That's what this summation, that's what that little symbol there tells me to do. It tells me I'm going to be adding them together. That's the Greek word sigma, Greek letter sigma, and it tells me to add in math. So I'm going to be adding these together. Now, what I'm going to be doing with those j's is right here. I'm going to be multiplying them times 12. So when j is 1, I'm doing 1 times 12. When j is 2, I'm doing 12 times 2. When j is 3, I'm doing 12 times 3. When j is 4, I'm doing 12 times 4. When j is 5, I'm doing 12 times 5. And then finally, when j is 6, I'm doing 12 times 6. Those I have to add up. So grab your calculator and let's add them up. Getting 252, and that's the answer. Ooh, Lee, how come you got 180? Okay, and that'll make all the difference. So 252, that is the answer. The answer is, what do you get when you add them all together? Not all of these, it's the addition of them. So 252 is the answer. Let's do another summation. I'll give you the little sigma. We've got k equals 1, that's where we'll start, to 5. And then we'll use that for our work. So 6 is how many j, so 6 is how many j equals there are. Yeah, there are 6 because you're going to go from where j equals 1 to where j equals 6. So I set those up where j equals 1, that's 12 times 1, all the way to where j equals 6, that's 12 times 6. You okay with that, Chloe? This tells you the math that you're going to do. You're going to take each one of those j's and you're going to multiply them times 12. So the first time when j is 1, we put a 1 in there. It's just a plug-in. Then when j is 2, we put a 2 there, 12 times 2. Until j is 6, and we put a 6 there. 12 times 6 is 72. And then we turn around and add all those guys up. You're welcome. To fan you. You're welcome. Okay, let's do the same thing. We're going to go from where k is 1, when we're going to plug 1s in here, until k is 5. That's what this notation tells us to do. I got kind of a little too close to the previous one. Let me just circle it so you know there's the problem we're doing. It tells us to start where k is 1, and we're going to climb up to where k is 5. So I'm going to have a k is 1, a k is 2, k is 3, k is 4, and k is 5. I know I'm going to be adding those up. I'm not going to put plus signs. That looked a little cluttered right there. I'm just going to have the 5 different problems here. I know I'm going to add them up. That's what the sigma tells me to do. Okay, so when k is 1, let's take this work and do it. That'll be a 1 times 1 minus 4. That's a 1 times negative 3. That gives us a negative 3. When k is 1, we plug in 1s there, and we get a negative 3 for that. Now let's go do the next problem. We're climbing from 1 to 5. Let's go do where k is 2. So I'm going to plug it into this formula. 2 times 2 minus 4, which is 2 times negative 2, which is a negative 4. Then I'm still climbing up from 1 to 5. I'm going to plug in 3s. So I'm going to plug in 3 times 3 minus 4. That's a 3 times negative 1. It gives me a negative 3. Almost climbed all the way up. Now I'm going to plug in where k is 4 into this equation. See, this is so compact. It tells you where to start. It tells you where to stop. It tells you what to do to each of those numbers, and then you've got to sum them up. So every single thing in here matters extremely. So let's plug in 4s. We've got 4 times 4 minus 4. That'll be 4 times 0. You know what that is. And then finally, we're at the top of the mountain here. We're going to plug in 5s. So 5 times 5 minus 4, which will be 5 minus 1, or 5 times 1, which will give us a 5. And now this sigma tells us we're going to be adding all of these together. So let's see, we got a negative 10 there and a 5, so that's going to give us a negative 5. So the answer to this bunch of symbols is negative 5. That's the answer. This tells you everything you need, where to start, where to stop, to add them all up, and what to plug in. Let's do that again. Although this one will not be, this one's sort of one of those tricky ones. So, Chloe, I know you were a little bit confused here because that was the first time we'd done it. Did the second time help you? Are you completely confident on this? Charles, okay, good, Chloe. Charles, yes, you're always going to be adding because that's what that symbol tells you to do. That's called summation notation, this kind of structure, and summing is its name. So you're always going to be adding the pieces together that you get when you plug in from 1 to 5. Always. Okay, let's do one more. Let's do the summation notation symbol again, which you will not have to reproduce. You can do whatever you want, you know. I equals 3. Let's start where I equals 3. Let's stop when I equals 7. And 12 is what's going to show up out there. Well, that seems weird because there's no I, but let's see how this goes. Again, we're going to need where I equals, we're going to plug in where I equals 3, where I equals 4, where I equals 5, I equals 6, and I equals 7. So we've taken care of from 3 to 7. There are 5, 1, 2, 3, 4, 5 different problems. This tells us what to do with each I. This tells us our work. And the work doesn't say 12 times I. The work says 12. I mean, here we had 12 times each of our J's. 12 times 1, 12 times 2, 12 times 3, till 12 times 6. Here we had a little bit messier. Here it just says 12. So when I is 3, the answer is a 12. When I is 4, there's nowhere to plug in a 4. It just says the answer is 12. When I is 5, this does not say 12 times I or I minus 12 or anything. It doesn't tell us anything to do except to write down a 12. Same thing here and here. And then this symbol right here tells us that we are summing these. We are adding those together. That's your job, is to add them together in the end. The answers that you get, add them together. So we get a 60 for that. 12 times 5 is 60. Okay? Then they're going to give you a little bit of practice undoing that. They're going to give you this kind of thing, and you've got to build this. Let me show you how to do that. It's fairly straightforward, but it's going to feel weird because it's backwards. Trust your brain. Your brain can figure this out. If they gave you 1 squared plus 2 squared plus 3 squared plus dot, dot, dot plus 12 squared, and they're going to say use 1 for the lower limit, use 1 for the lower limit, and I for the index of summation. That sounds very formal. Okay, so that's the material you're going to be given. What you want to do is you want to build yourself a little summation. It will give that to you, but I want to show you how to work this. They've told you they want you to use 1 for the lower limit, which is good because 1 is the lower limit right here, and I for the index of summation. So they expect you to write I equals 1 down there, and that part you will have to supply. I equals 1. So I equals 1, where do we end up with? We end up with 12. The first number we used was a 1. The last number we use is a 12. Now, we're not going to have to do this work. We're just going to have to provide the symbolism. So we have one more little teeny weeny thing to do. We have to talk about what is happening to the 1, then the 2, then the 3, then the 4, then the 5, all the way up to the 12. You can see that they're each being squared. So we're taking our I and we are squaring it. And that's all they want from you. We're done. They're telling you to use 1 for the lower limit and I for the index. So I equals 1 is what you'll write here. So that means that this should be a 1, and it always will be a 1. It's not going to be a 5, and you have to figure out what the hell happened from a 1 to a 5. It'll be a 1. So we're going from 1 to 12, as you can see, from 1 to 12 there. They start at 1, put the 1 down here. They finish at 12, put the 12 up there. And then you've got to figure out what's happening to each of these i's. Well, they're each being squared, and that's what your answer is. So this is what you're looking for. Let's do that again. We give you 1 plus 2 plus 3 plus ... plus 35. And the same instructions. Use 1 for the lower limit. And I for the index of summation. Okay, let's build one of these. They will give you the symbol that tells you you're supposed to be adding them together. They'll ask you to write this in, and they're telling you to use I, and they're telling you to use 1. So I equals 1. At the top, you want to put the last number, the upper limit, the last number used. You're starting with 1, you end up with 35, so you'll put a 35 up. And then each of these is a progressive I, is a subsequent I. Even easier than that, Chloe, because when we had 1, we didn't add 1 to it. We just had I. It's just I. It's the number itself. The next one would be 2. Then the next one would be 3. But the first one is just I equals 1, and that's I. So really, it's not going to be difficult. And that's the answer that they're looking for right there. And yeah, Lee, I think you got it. Good. Okay, let's do one more teeny weeny thing. It says use a calculator here. I would not use a calculator. Heck no. Going to give you 215 factorial over 212 factorial. Okay, let's see if we can even do that. Let's see, 215 PRB, scoot over, hit that, equals. Nope, can't do that. We'll use a different, well, we'll use a calculator, but we won't use it to figure this. You need to know that this means 215 times 214 times 213 times 212, etc., divided by 212 times 211, etc. Those will cancel. So this is the work that you need to be doing to evaluate this. So 215 times 214 times 213. It's giving me 9,800,130. So 9 million, almost 10 million. Okay, that's the answer of 215 factorial over 212 factorial. So you need to understand that this one will pick up the slack for the rest of the top one, and you can just cancel those out. Okay, we are done with 6.5 and 8.1. We'll do arithmetic sequences. That's where you're adding in something each time, plus 5, plus 5, plus 5. We'll do geometric sequences and series next week, which is where you're multiplying each time, times 5, times 5, times 5, that kind of thing. Super easy. And then on Wednesday, we'll review for test 4. We will have Wednesday, Thursday, and Friday to take that test. The next week, we'll review on Monday and Wednesday, and you'll have Wednesday, Thursday, Friday to take your final. This review for the final will look so much like what we've been doing when we do reviews. I'll give you the review. It'll have a few more problems. I think it has 50 problems on it. Your final, I wish I could remember how big your final was. It's about 40 problems, I think. It's not enormous. And you'll have 2.5 hours to take it. It doesn't take that long to take it. It'll be, you know, you're good. You're good. And this is a really good review for the final. It's not like, well, good luck, figure it out. It's like our other reviews. It's very much like the final. So we have 1, 2, 3, 4, 5 more classes. 3 of them are review. We are so close. So 5 classes left. 3 of them will be review for this test, 2 reviews for that. So we've only got 2 more new days. They're very easy. And then 3 more reviews. So you are almost finished. Almost finished. Hang in there. You can almost not do anything to your grade. I mean, you guys that are going to pass are going to pass. You're there. Just gotta see it to the finish line. Okay, I'm going to stop recording here.